Over the last year, I have built a redstone computer onto Whimsycraft SMP in survival. I am 90% finished, but sadly the season ended on June 15, so 3 days ago, or I don't really know when I will upload this video. Okay, let's talk about what I finished and what this thing can do. The first thing I want to talk about is the display. This is the GPU that controls the logic behind the display. The part here with the sandstone walls and the blocks next to it, this is the graphics memory. Here are all the numbers and all the characters and symbols stored, how they should look like on the display. Okay, this down here with all the glass, that's just the logic for controlling which pixel should be activated. Behind here is the storage for the lines that are drawn to the display. So I think there are a total of 12 times 4, so 48 lines that can be stored. And exactly, and down here is the logic for receiving some commands from the CPU. Okay, now let's go to this thing here. This giant thing here with normal terracotta. That is the queue, I think you could call it. The queue from the keyboard. So the display or the CPU only can take a new input every 2 seconds. So if there is more, if you input like 2 numbers in 2 seconds, it could only accept 1. So this is a queue that stores the inputs, and it is really, really fast in storing. I think you can store a value every 4 ticks or so. So 5 values can be stored per second, and that's much more than ever needed on the keyboard. Exactly. And then the stored inputs are one after another sent to the display or the CPU. Now, the next part. This green thing here is the command parser. As I have shown before, like commands like /write, I are implemented. Yeah, that's what I want to say. And this is the logic for controlling that. So it's basically just checking for a sequence of characters. And in here is decoded by redstone torches and redstone how the first character should look like. Then if the first character comes in here and is correct, this enables the second checker to check for the second character, and if the second character is entered correct, this enables the third checker, and so on until the complete string is correct. If there is a false number entered to the string, then it instantly stops and only will activate again with the next slash. And the slash is detected here. Exactly. Okay, this up here is a program counter. I think this one also works on a 4-tick basis. It's completely overpowered for this redstone computer. The redstone CPU runs on a 64 game tick clock, which is extremely slow, but it's in survival and it's my first redstone computer ever, so I don't care. This thing down here with all the node blocks and observers, that is the program memory, where the program is stored, exactly. And it's stored with observers and pistons, and if the line above is getting power, the pistons push the observers down and the observers activate the corresponding line. Yeah, exactly. The green line is in 4-bit opcode, and then there is 16-bit other code for the registers and so on. And each register, how do I say that? No, I only have 15 registers, and then for like numbers or so, there can be loaded integers into a register of a size of 10-bit. Okay, this thing here with the light gray terracotta, this is the register file. It's overkilled, and after building this and designing it for myself, I came across some videos about much more efficient and much smaller register files. But yeah, I wanted to design this thing at least in many parts by myself. Okay, let's come to the next important thing, the main bus. I decided to use only one data line for sending instructions. So for example, if you want to add 2 + 1 and then the result 3, the 2 needs to be grabbed, I say, from the register file and be brought to the adder. Then the 1 needs to be found and grabbed and to be brought to the adder, and then the result is again over the main bus brought back to the register. This results in very long waiting times because the first register has to be sent, then there's a delay before the next can be sent, then the second register, and then the result has to be sent again over only one bus, and so that the signals don't overlap. Yeah, it's very, very slow. Okay, the red part here is for the logic, so and or not. The part here is for it's for equals, less than, and greater than. The part here is for shifting, and it's very interesting how I designed it. At least I think that it's very interesting. It can shift in register, or it can shift an input up to 16 times in 32 game ticks. Not super fast, but 16 shifts in 32 game ticks actually makes a shift every 2 game ticks, and that is a very decent rate. So yeah, exactly. And that was most of it. Yeah. Okay. For the end, I quickly show the base I have built. Here is a little storage system with all the items that get automatically produced. Here's the stuff that isn't automatically produced. And this here is my redstone biome. So I tried to design this so that the farms and the output of the farms runs on the overground, and everything looks like it's like a big redstone infection that's harvesting resources from the environment and so on. Exactly. And here's everything full of farms, an auto smelter. Down here is a mob farm, a giant kelp and bamboo farm, a giant cacti farm, a piglin farm for gold, a little netherwort farm, and the coolest farm, I think, is a fish farm in a completely normal river. So you don't have to try out this river to get a lot of fish. I think it not perfectly blends into the river, but it leaves the river very natural, but also generates a lot of fish. Yeah. Okay, and as many projects on I start again. As you can see, this project was also not completely finished, but I'm still very happy with how it came out, and I really like the look of the space. Okay, and I think that was everything I wanted to show, and I can now happily leave the season behind me and only sometimes return in good memories on this thing. See ya!